Building a cross-platform app today usually comes down to three choices: Flutter, React Native, or Kotlin Multiplatform. At first glance, they all promise the same thing: one codebase for multiple platforms, which brings faster development and lower development costs. Hello everyone, my name is Aleksa, and I've spent the last 10 years of building mobile applications for enterprises and startup companies. In this video, I'll walk you through each of these frameworks, explain their strengths and weaknesses, and how they fit in real-world projects. I'll share my personal and my team's experience with all of these technologies and share some recommendations about what technology would I choose if I would be starting a new project today. So let's get started. I will start this comparison with the newest framework, Kotlin Multiplatform. Kotlin Multiplatform is a cross-platform technology developed by JetBrains, which allows users to share a business logic but keep the UI parts of it native to each of the platforms. This approach reduces duplicated code by preserving native user experience. Advantages. The biggest advantage of Kotlin Multiplatform when compared to other cross-platform solutions is that it brings you the native performances, which isn't particularly something which you'd expect for a cross-platform framework. We noticed this ourselves when we migrated our first Kotlin Multiplatform project. The reason for this is simple, because Kotlin Multiplatform doesn't rely on an additional rendering engine between the apps and the platforms. Another great thing about Kotlin Multiplatform is that it relies on the same language and the similar architecture as an existing Android native application. And that means during the migration process, you don't need to rewrite the whole code base from scratch. You can start with what you already have in place. In some cases, we were able to migrate the app to Kotlin Multiplatform in just under a month. But of course, it depends on the project complexity. Since the UI is still being built natively on Android and iOS, we can build interfaces which feel natural to existing iOS and Android users and produce a much better user experience. Disadvantages. Unfortunately, Kotlin Multiplatform doesn't eliminate the need for having iOS engineers in your team, because the iOS part of the UI is still being built natively through SwiftUI or UIKit. For example, our Android engineers who are working with Kotlin Multiplatform and write the shared business logic and Android UI are still dependent on our iOS engineering team, who is responsible for building that same UI just on the iOS side. As a result, the percentage of the code shared between platforms is lower than when compared to other cross-platform solutions. Another challenge my team faced is immature ecosystem and support from the community. At the time when we started working with Kotlin Multiplatform, there weren't many available libraries, communities, and online resources, so we had to figure out a lot of things on our own. But that's changing quickly. Now we have a lot of available Kotlin Multiplatform libraries. The framework itself has matured and is currently one of the fastest growing cross-platform frameworks. If you have a large and complex native application across iOS and Android, which relies heavily on performances and platform-specific features, then Kotlin Multiplatform would definitely be an option you should consider. That same applies if you already have a native app. Instead of rebuilding everything from scratch, you can just build new features with using Kotlin Multiplatform and then eventually migrate the entire code base to KMP part by part. Doesn't that sound amazing? Flutter. Flutter is a cross-platform framework developed by Google, which allows developers to build iOS and Android apps from a single codebase with using Dart as a programming language. Compared to other mobile development frameworks, it doesn't rely on native UI components. Instead, it uses its own rendering engine to draw elements on screen, giving the developers full access to the interface and interface customization, and ensuring the consistency between platforms. The basic component in a Flutter program is a widget. A widget describes the logic, interaction, and the UI of an element. Advantages. What I really like about Flutter is how quickly you can build an app for iOS and Android with using Flutter as your cross-platform framework. We once worked with one of our clients who wanted to build an iOS and Android app in a really short amount of time. Only one of our developers worked on the project, and within 3 months, the app was already live on the App Store and the Play Store. Hot reload is one of the really cool things about Flutter, because whenever you make some code change and you want to see it, how it will be looked on the UI, you don't need to rebuild the whole app. It will become visible right away. And of course, as many other popular cross-platform frameworks, Flutter has a list of pre-built UI components. So if you decide to go with Flutter as your platform of choice, you won't have to rebuild all of your UI from scratch. You can use the existing packages. Disadvantages. As good as all of these sounds, Flutter is far from perfect. All of these advantages for the developers come with a serious trade-offs. With using Flutter, you can build apps almost twice faster as when compared to building native iOS and Android apps. But that comes with a cost. Flutter uses an additional layer between the app and the operating system, which can lower the performances of the app, especially in high demanding applications. You can imagine opening a delivery app and waiting for 30 seconds just to see which items will you order. You would probably get frustrated really quickly. And finally, Flutter doesn't work equally well on both of the platforms. For example, if we have a Flutter application which was designed having Android ecosystem in mind and it has a back button on the top left corner, if the user opens that app on an iOS device, the navigation for them would probably not feel that natural and he could easily get confused. Best use case. Flutter is a great choice for companies who want to build visually rich applications while maintaining a single code base. React Native. React Native was developed by Meta in order to help developers which are experienced with TypeScript, JavaScript, and React to be able to build mobile applications. So unlike Flutter, it doesn't have its own rendering engine. Instead, it relies heavily on native UI components for Apple and Android, and that results in a much more native feel which React Native applications have when compared to Flutter apps. Application logic runs inside the JavaScript runtime, where React Native essentially acts like a bridge between the JavaScript code and platform native APIs. This allows developers to share a significant portion of their code base while maintaining the access to native features like camera, GPS, and more. The basic building blocks of React Native applications are components which define structure and behavior of React Native application. Advantages. One thing I really like about React Native is how quickly you can adapt an existing web application to a mobile application using React Native. For example, we had one of our clients which had an existing React app and wanted to ship it also to iOS and Android. We decided to go with React Native, and we have just adapted things like mobile navigation, theming, and push notifications. Thanks to this approach, the project took around 60% less time when compared if we would build out that application from scratch with using any native framework or even a cross-platform framework. Disadvantages. Challenges with React Native come in a way the JavaScript code is communicating with the native layers. While the difference is not noticeable in most of the application, some of the React Native applications tend to have issues with performance. That means slower application and more time spending waiting on something to load. Dependency management in React Native is also one thing which can get pretty complex as the project grows because you're relying on too much of the third-party libraries. And finally, applications with animations and performance-heavy features can require some additional modifications in order to make sure that React Native app displays them smoothly. We had a client with a big app written in React Native who started complaining that the app started to feel laggy. So we decided to move it to Kotlin Multiplatform. After that, all of the performance issues were resolved. And that's why I recommend using React Native only in specific situations. React Native is perfect for companies who already have an existing React web application and the team which is experienced with JavaScript and React. React Native in that scenario can help them get to their mobile app much easily. A short summary of what we covered in this video would be the following. You should probably go with Kotlin Multiplatform if you already have an existing iOS and Android application and you want to share a portion of your business layer. You can start by migrating only parts of your application to Kotlin Multiplatform and then eventually migrate the entire application to the KMP. On the other hand, you can use Flutter if you want to have consistent UI across iOS and Android app and if you want to move fast and deliver product to market. React Native is perfect when you have an existing React web application and a team skilled with JavaScript, TypeScript and React, and you want to port that existing solution to a mobile application. When I first started my iOS journey 10 years ago, there was pretty much no discussion. If you wanted to have native performances, you would go with iOS native and Android native. But a lot has changed over the past few years. 3 years ago, my coworker came and said, let's try Kotlin Multiplatform. I was a little bit skeptical at first, but after diving in deeply into the Kotlin Multiplatform and seeing what it can do on some real-world projects, we decided to give it a go. What really surprised me about Kotlin Multiplatform at that time is how different it was when compared to other cross-platform technologies. For example, you could decide what you want to share. You could share only networking layer. You could share only business layer. You could share entire view models. It was completely up to you. We decided to go all the way and share view models between iOS and Android apps. The only thing which remained native was UI. We used Swift UI to write the UI on the iOS side and Compose to write UI on the Android side. At that time, it felt like we managed to get the best out of both worlds. We were able to share the business logic and save some time, have some consistency across our Android and iOS app, but also have native performances on the iOS and Android side by writing UI natively. Of course, Kotlin Multiplatform was not perfect at that stage. It was really not mature, a lot of tooling was not there, so we kind of had to figure out a lot of things on our own. We spent a lot of time learning, experimenting, and then gradually introducing it to more projects. And today, after several years of using Kotlin Multiplatform extensively, I can say that my perspective of cross-platform frameworks has changed completely. In the end, I am still the person who prioritizes native performances. So if you would ask me, Aleksa, what is the best cross-platform framework to use? I would say it depends on your project, but I would strongly advise you to think about Kotlin Multiplatform. I really hope you found this video insightful, and if that is the case, subscribe to support us. Also, please let me know in the comments which one of these cross-platform frameworks you had a chance to try out yourself. If you want to learn more, feel free to go to our blog where we share more of these things in detail. Thank you for watching everyone, and see you in the next video.